Hi, today we're looking at proving conjectures using deductive reasoning. So we'll go through some definitions as well as do some practice. So first definition is proof, which is a mathematical argument showing that a statement is valid in all cases or that no counterexamples exist. So essentially, if we're able to do a proof, which usually in most cases involves variables, and it shows that a mathematical argument works, then there shouldn't be any counterexamples to it available. And a generalization is a principal statement or idea that has general application. Okay, so we'll do an example. A student has discovered a pattern when adding integers. So if they go 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, that gives them 28. Where if they do 11 plus 12 plus 13 plus 14 plus 15 plus 16 plus 17, that gives them 98. And if they take negative 15 plus negative 14 plus negative 13 plus negative 12 plus negative 11 plus negative 10 plus negative 9, that gives them negative 84. Now with this, they claim that when you add 7 consecutive integers, the sum is always 7 times the middle term. So what we're going to do first is test the solution with numbers. We're going to take those equations that they have and find our middle terms and multiply them by 7 to see if that does actually indeed give us this last term. So in this first one, our middle term is 4. So if we go 4 times 7, that does indeed give us 28. This one, our middle term is 14. If we go 14 times 7, that gives us 98. So far it is working. So this next one, our middle term is negative 12. Multiply that by 7, that gives us negative 84. So far it does work. Now, before going on to do a proof, we'll try one more example because although we have tried some small numbers as well as some negative numbers, we have not seen if it'll, for example, work with large numbers, which is one of the places lots of conjectures fall apart. So we're going to try a sample with larger numbers. So for example, we could say 200 plus 201 plus 202 plus 203 plus 204 plus 205 plus 206, and that gives us 1,421. Now, if we take our middle term, go 7 times 203, that gives us what we had here. So it looks like this does indeed work. So to prove that it works, we will do a proof utilizing variables. Now, because in our conjecture, we said the sum is always 7 times the median of the numbers, we will make our middle number x. So first, we know we've got 7 numbers, so I'm just going to put in essentially 7 blanks. Now we said our middle number is x because we're going 7 times that middle number. Now, if we're doing with consecutive numbers like we are with this conjecture, that means that as we increase, we're just adding 1 to our value to get the next one. So therefore, this value would be x plus 1. If I add 1 to this, that gives me x plus 2. If I add 1 to this, that gives me x plus 3. Going the opposite way, as we're going down, we're constantly taking away one number. So we've got x minus 1, subtract 1, so that gives us x minus 2, and that gives plus x minus 3 for this one. So what we'll do now is add this together, so correct right term. So we have x plus x giving us 2x, plus another x giving us 3x, plus another x giving us 4x, plus another one giving us 5x, plus x is 6x, plus x is 7x. Now if we have negative 3 minus 2, that's negative 5. Minus 1 is negative 6. Plus 1 is negative 5. Plus 2 is negative 3. Plus 3 is 0. So all of our constant terms cancel out. So essentially this is our answer, 7 times x. So we have proved that 7 times our middle number will give us our solution. And we can say something along the lines of, since x represents our middle term, seven x will always represent our sum. Of 7 consecutive numbers. Okay, so we'll look at a couple more definitions. So deductive reasoning is for proving of conjectures with variables instead of substituting in numbers. So deductive reasoning is essentially proving that things work, not just looking at patterns and coming up with conjectures. Inductive reasoning is when we're looking at our patterns and coming up with conjectures by using general assumptions. Next example, prove a conjecture that the difference between consecutive squares is always an odd number. Now, the key to this question is knowing what various words mean in terms of their mathematical meanings. So difference means we're going to be doing subtraction. Consecutive just means in a row. And squares, that would be like 1 squared, 2 squared, 3 squared, and so on. So we want to show that it's always an odd number. So what I'll do is I'll say that my first number is equal to x. And then if I've got consecutive numbers that are in a row, so my second number can be one of two things. Either way, we'll get the same answer in the end. So it could be x plus 1, because that's 1 more than this, or it could be x minus 1, which would be 1 less than this. Now, typically, if we were looking at the difference between consecutive numbers, we're usually taking our larger number, subtracting our lesser number. So in this case, we'll take our larger number, which is x plus 1. It's a square, so we're squaring it. And then we're minusing our first number squared. What we'll have to do with this is expand this out. So x plus 1 squared is the same as x plus 1 times x plus 1 minus x squared. Now what we'll have to do with this is FOIL. So for those that do not remember what FOIL stands for, F is first. So that means we're multiplying the first term in each bracket. So x times x is x squared. O stands for outside. So that would be outside terms. So x times 1, so plus x. I stands for inside. So the two inner terms, so 1 times x gives us x. And then L stands for last. So we have 1 times 1, so it'll be 1, and then we've got this minus x squared. So now we'll combine like terms. We've got x squared minus x squared, so those are just going to cancel out. And we end up with 2x plus 1. Now, if you notice this term here will always give us an even number. As long as that x value is an integer. And looking at this, we are adding essentially an even number. And an odd number. Therefore, we will always end up with an odd number.